Recording is rolling. It's Tuesday, March 3rd. How do you guys do this Toothpick Bridge project? Build Toothpick bridges. All right, so here's an example from the past. All right, you guys can see like one idea. Right, guys, this. Right. So it's gonna be engineering week. Speaking of engineering week, actually, before I get to this, yesterday showed you guys the civil engineering presentation. I told you guys I might bring this in. So this is from 2008, back when I was in college, my undergrad years. So we cast these molds. And since American University, we're working in American units here. So it says a diameter of 4 inches, 4 inches. Okay. This used to be 8 inches tall, used to be. Okay. And it took, I think, a week or two for these to cure. Right? No, we made different molds, different kinds of concrete, maybe different mixtures of water versus aggregate and Portland cement. Right? And we were going to test their strength. You guys saw on the slide yesterday, you can put this cylinder in that compressor and it'll smash it and it'll figure out how much pressure, let's say stress that you can put on those. If you know the cross-sectional area, you can multiply it to get what force it can carry. Then you can calculate how tall can you build a building with this concrete. Yeah, so I've been holding on to this for almost 2 decades now. Got that. Okay. All right, so back here. So doing engineering. You guys get an engineer's pitch. Oh, I let you guys off with a question yesterday. Okay, so I'll round back around to that question too. But let's look at this project first here. So I'm going to give you guys 250 toothpicks. That's one box of toothpicks. One per team. If you want to split it to make smaller teams, you can do that. I'll just give you guys another box of toothpicks. Got plenty of boxes. Okay. And then, today, tomorrow, and Thursday, put these bridges together. Now, this takes some patience and thinking. It takes time for this glue to dry. You guys get some Elmer's glue. And your goal is to span a 20-centimeter gap. So on Friday, I'm going to set the depth up with a 20-centimeter gap. Hey, guys, if it's a 20-centimeter gap, do you want to make your bridge, exactly 20 centimeters long? Is that how you want to make your bridge? No, because it's going to fall down. It'll be a wreck. So how about probably at least 25 centimeters here, I think? You do a couple centimeters here, a couple centimeters here, and of course you can go longer, but you don't want to do it shorter than that. Okay, this one right there. All right, and then, then when I set this up, okay, so there'll be a 20-centimeter gap. Right, I'm going to set your bridge, across that gap. Okay. Then on top of that, I'm going to set this roll of tape, which should be about 8 centimeters diameter, I think. Yeah, that's about 8 centimeters diameter right there. Okay. Then I'll take this gray tray that you guys turn your assignments in, and I'm just going to start stacking lab weights in there. We're going to see whose bridge can hold the most weight. All right, so you guys get that? Good. All right, now, if you look at the cross section of this bridge, this will link back to maybe a question I asked you guys yesterday. Like if you're driving through this, driving through. Right, see what that looks like. Okay. I wonder if it would be stronger that way or that way. You think of that? Okay, here I got another bridge, also from the past. Okay. This one's got a little bit. Ideally, the paper should not be a structural material. So if a little gets stuck on there, then that's all right. But you're not really using the paper structural. Okay. So I asked you guys a question yesterday. And we'll run back today. So I said, what would be stronger? Should you have a cross section that looks flat like this, and maybe a flat long bridge? Okay. Or should you go with a tall skinny bridge? Maybe somewhere like that. Okay. Again, you guys know I'm putting a boat on the top like this, and you're gonna have the supports on the ends, like here and here. Okay. So is this both these bridges want to kind of been like a smiley face, don't they? Been like that. Okay. So which one of these bridges do you suppose would hold more weight? The one left or the one on the right? Let me see. Show of hands. How many guys went home and thought about this? Okay. How many guys think the one on the left would hold more weight? How many guys think the one on the right would hold more weight? Okay. All right. How about this? I got another question. You guys know a 2x4 piece of wood? 2 inches by 4 inches. Actually, modern day they slim it down a little bit, so it's a little smaller. But they still call them 2x4s. Okay. But if you have a plank of wood, and I orient it like this, versus I turn it 90 degrees and orient it like this. Which orientation? Okay, and the same support. So supports on the ends, and I'm going to put a big old weight right in the middle. Which one of these 2x4s is going to hold more weight? The one on the left or the one on the right?
One on the right.
Right. Show of hands. How many say the one on the left? How many say the one on the right? Okay. Yeah, see a bunch of hands on this one. And also, back when with the bridges, I saw a bunch of hands on this one. Okay. Hey, aren't these kind of the similar concept? Yeah. This one on the right will hold more weight. Okay. So that might be one tip for you guys for when you think about how to design your bridge. All right, so here, I put this up here for reference. Put this up, and let me get you guys your toothpicks and glue and friends.